go over our integral exponent exercise solutions. So first up for the example, let's use the properties of exponents to simplify and make sure we have no negative exponents. So the first one, negative 3 raised to the third power. Remember what it means to raise to the third power. You take the base and multiply it to itself 3 times. So we're going to take negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is positive 9 times negative 3 gives us negative 27. If we wanted to take negative 2 raised to the negative third raised to the negative second, power of a power, we take these two powers and we multiply them together to get negative 3 times negative 2, which is positive 6. And then we'll take the base 2, multiply it to itself 6 times. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. 5 to the 7th over 5 to the 5th. Like bases being divided, we'll subtract their exponents. So it'll be 5 raised to the numerator exponent minus denominator exponent, which gives us 5 raised to the 7 minus 5, which gives us 5 squared. So we'll take 5 times 5 to get 25. Here we have 3x squared y to the negative 1 all being raised to the negative 4th. Power of a power. As long as you don't have addition or subtraction going on inside the parentheses, you can distribute that exponent. Just remember, everybody inside needs to get that exponent. So this 3 has an exponent. It's really a 1. So when I distribute this exponent by multiplying, I need to multiply it right here as well. So that's really 3 to the 1 times negative 4, x squared times negative 4, y to the negative 1 times negative 4. That gives me 3 to the negative 4, x to the negative 8, y to the 4th. Now, remember what it means to multiply or raise something to a power. You multiply it to itself that many times. Well, you can't take 3 and multiply it to itself negative 4 times. You can't take x and multiply it to itself negative 8 times. You can't do anything a negative amount of times. So in order to be able to solve this, we will have to get rid of those negative exponents. And remember from the properties from the previous video, in order to get rid of negative exponents, you move it to the other side of the fraction bar. If it's in the numerator, you move it to the denominator and make the exponent positive. And if it's in the denominator, you bring it up to the numerator to make it a positive exponent. Here, both of these are in the numerator, so we'll bring them down to the denominator. And now that I have 3 being raised to a positive exponent, I can take 3 times 3 times 3 times 3 to get 81. So I have y to the 4th over 81x to the 8th. Next up, we have 3x squared over 2y to the 4th, all being raised to the negative 3rd power. Again, we don't have addition or subtraction going on in the parentheses, so we can distribute that exponent. Just remember this 3 has an exponent of 1, and this 2 also has an exponent of 1. So when I distribute this exponent, I need to distribute it not to just this 2 and this 4, but also the imaginary one that's here and the imaginary one that's there. So then that would give me 3 to the 1 times negative 3, x to the negative 2 times negative 3, 2 to the 1 times negative 3, y to the 4 times negative 3. And then remember, we can't do things with negative exponents. We will have to get rid of them by moving them to the other side of the fraction bar. So here this 3 to the negative 3 is in the numerator. I'll move it down to the denominator. This x is in the numerator. I'll move it down to the denominator. This 2 is in the denominator. I'll bring it up to the numerator. And this y with the negative exponents in the denominator, I'll bring it up to the numerator. And now we can take 2 and multiply it to itself 3 times, which is 8. We can take 3 and multiply it to itself 3 times to get 27. And we get a final answer of 8 y to the 12th over 27x to the 6th. Next up, we have 6a to the negative 2, b to the 4th times negative 5a to the 5, b to the negative 7. Multiplication is commutative. You can multiply in any order you want. 2 times 3 is the same thing as 3 times 2. So since we're multiplying all of these, we can switch the order and we can multiply the numbers together, the a's together, and then the b's together. So then 6 times negative 5 is negative 30. Like bases being multiplied, I will add their exponents, and like bases being multiplied, I will add their exponents. So I get 6 times negative 5 is negative 30. Negative 2 plus 5 will give me a to the 3rd. 4 plus negative 7 gives me negative 3. But remember, we don't want negative exponents. So anything that has a negative exponent will need to move to the other side of the fraction. Well, this negative 30 doesn't have an exponent written, which means it's automatically a 1, which is not negative, so the negative 30 stays up top. The A will stay up top. Just this B will move to the bottom to become positive. So we get a final answer of negative 30 a to the third all over b to the third. Now here, your textbook likes to write it as a division sign, which is why I wrote it as a division sign. When you're taking 32 m to the third, n to the fifth, p to the negative 2, divided by negative 4, m to the negative 3, n to the 13th, p to the negative 2, that's the same thing as taking this entire term over this entire term. So now when you're dividing, we can divide the numbers, divide the m's, divide the n's, and divide the p's, so we can separate them if we need to. Now we can do 32 divided by negative 4, no problem. Like bases being divided, subtract their exponents, numerator minus denominator, here, here, and here. So when we do that, we get negative 8, m to the 3 minus negative 3, n to the 5 minus 13, p to the negative 2 minus negative 2. 3 minus negative 3, subtracting a negative becomes adding. This gives me 6. 5 minus 13, this gives me negative 8. Negative 2 minus a negative becomes adding a positive, and negative 2 plus 2 becomes 0. Now remember from our properties in the previous video, anything raised to the 0 power is 1. So this is really negative 8, m to the 6th, n to the negative 8 times 1. And anything times 1 is itself, so we're just not going to list it, right? It goes away. What you may have noticed is these are the same, and when you have something over itself like this, they cancel, and some of you may have canceled it all the way back there, and that's just fine. Now this n has a negative exponent that we'll need to get rid of by bringing it down, and we get a final answer of negative 8m to the 6th all over n to the 8th. So let's visit an application problem. On the New York Stock Exchange from 1970 to 2006, the average daily shares traded, which we'll call S, which is represented in millions of shares, can be approximated by the formula S equals 0.50274 times 1.1626 raised to the t, where t is the number of years past 1950. So what does this model predict for shares traded in 2006? So the first thing we need to see is that t represents the number of years past 1950. So we pretend like this model was born in 1950. How old is it in 2006? T represents its age. So the first thing we need to do is find t by taking 2006 minus 1950 to get 56. Now that we know how many years this model's been going on, we can plug in 56 into the model to get S will be this number times this number raised to the 56th power. And when we put that in our calculator, we get 2319.75. Well, it turns out that the actual numbers of shares traded in 2006 was 2,343.16 million shares. We predicted it was going to be 2,319.75 million shares. How do these answers compare? Well, considering that this is measured in millions, these numbers are really, really close, so it was a pretty good model. All right, that's it for now. See you next time.